Okay, hi everyone. Welcome to the MLOps Live webinar series and to today's session where we'll be discussing and demonstrating CI/CD for machine learning and MLOps using GitHub Actions. My name is Sahar and I'm Iguazio's VP Marketing, and it's great to have so many of you here with us today. A few housekeeping rules before we get started. You're invited to ask questions using the panel at the bottom of your screen. We will take a few questions after the first part of the presentation because we've got lots to share with you today, and we'll leave time for more questions at the end. We'll be running a short 2-question poll during the session. It is completely anonymous, and please do fill that in, and we'll share the results with everyone at the end. We've now put everyone on mute. The session will be recorded so that we can send it to you afterwards. And we've got a great webinar planned with lots of cool stuff to show you. So I will now hand it over to Iguazio's co-founder and CTO, Yaron Haviv, who will introduce the session and our very special guest speakers who are here with us today. And we're really thrilled to have you all with us.
So thank you, Sahar. And I have a pleasure of introducing our guests for this week. So we have David Aronchik, who's the head of open source machine learning and AI strategy at Microsoft. Anyone who knows David, he knows he's also the guy behind the Kubeflow, the open source project for machine learning on Kubernetes. And we have other members from Microsoft and GitHub. And the topic of today is how to essentially leverage the Git process as an automated mechanism for launching pipelines for machine learning, tracking the execution, and administrating this entire process and leading into production in a simpler and faster way. Next, Sarah. What we're also going to see today is essentially a presentation from David, followed by a couple of demos. There's the main demo using Microsoft and GitHub tools, and then I will also show a small demo how we did something similar using open source projects like Kubeflow and MLRun and others to essentially do the same. So this is, if you look into the entire process of machine learning, we have all those things that we need to do anywhere from development of code to packaging and scaling out code and tuning and instrumentation, and finally automation. This time we'll focus on the automation. So Sarah, can you skip into, not this one, the couple ahead? Those are for the end. So we want to create essentially a full workflow where we collect data, we prepare data at scale, we run training, and finally deploy those models to production. And what we'll see is how we leverage the Git process, which is used for software development, usually for agile software development, how we leverage essentially the same process for machine learning with the help of David and the other members. Next. So with that, we'll start with David.
Sorry, always good to start on mute. This is very nervous for me. Normally, I would have a bookshelf behind me full of important books indicating how smart I am. So now I'm just relying on my words, which is always very nerve-wracking. Anyhow, thank you so much for the opportunity to Yaron and Sahar and all the team at Iguazio who have given us the opportunity to talk about this. Today, we're going to be talking about how to productionize your ML using standard tools available on GitHub, and walking you through exactly what that looks like. Next slide, please. So at Microsoft, we have quite a bit of experience doing machine learning. You can see here that machine learning touches just about every single one of our product lines, from consumer to enterprise, games, GitHub, search engines. We use machine learning for everything. Next slide. And the big reason we do is because the volume of data that we have to process through right now is so large that there simply aren't tools available other than machine learning to look at this. You can see here over 180 million users a month access AI-generated models on Office, 18 billion questions asked of Cortana, 6.5 trillion events analyzed every day on behalf of users for security incidents. The volume of data is so large that there's no way that we could build a simple program to do this, we would have to make sure that it was available through models and sophisticated data analysis. Next slide, please. And we always want to give back. A lot of the models that you see here, we work upstream to beat human comprehension around a number of very specific domains. Next slide, please. Now, as an industry, I think we don't do a great job because we say all these great numbers and we talk about better than human performance and how it impacts every one of our areas of business. But then at the same time, we leave a real lack of tools in the hands of data scientists and ML engineers. Next slide. And a lot of the time is because we sit here and we focus on big things like building a model. And don't get me wrong, building a great model is very hard. Next slide. But building a model is just one of a very small amount of overall components. Next, please. Oh, sorry. As you can see, real models that are used in production in the real world have deep pipelines. And those pipelines often touch many different disciplines. That's a challenge to wire those together, to make sure they're operating properly, to make sure your CI/CD system is smart enough to work through that can be a real challenge. Next slide. Now, we have seen this before in the world. This used to be the case around development, but then there was an advancement, next slide, around GitOps, where you would have the developer on the left-hand side do quick iterations with their overall work and always be integrating using Git into the central repository to make sure that they weren't far off and that they were following some standards. Those standards could then be used to push forward and allow the developer control over deployment to say, hey, this needs a certain CPU or this needs a certain amount of memory. And they could do that and dictate that. And the SREs and the engineers would be able to roll that out according to the developer's criteria. It gave them both velocity and security at the same time. Next slide, please. So what we need is Git plus dev plus ops plus ML. And that is MLOps. Now, next slide, please. The way that works is we add another circle to what you saw before. Again, you'll have the data scientists doing what they understand very, very quickly, iterating on their model using Jupyter and the local tools that might be available on their laptop. And next, please. And they'll fold that into the overall process of development and operations as you saw before. And now what you're doing is you're bringing in those data scientists in from the cold instead of having them be far away and potentially out of sync with the main path of development. They're using the same tools that any other app developer is using to roll things out. Next slide, please. But MLOps is unfortunately hard today. A number of reasons for this. Next slide, please. You can see a lot of them here. Things can be hard to set up. The handoffs aren't clean. We don't give tools, the same tools to data scientists that you would use for any of your other applications. Oftentimes your code is very separated from your model, which can lead to drift very quickly. And one of the biggest things is that last one, where you have the data scientist operating in the environment that she sees fit, again, her laptop or her private cluster, and then when she decides to move to the cloud, it often is an entirely different environment. So next, please. Our solution is to give data scientists control in the same way that we gave application developers control in the past using GitOps. We're going to do the same thing, but through MLOps. Next slide, please. Now, the way to do this is to make MLOps easy. Next. Or easy-ish, because nothing in computing is ever, truly easy. Next slide, please. And the way to do that is to focus on these three core components. The first is around ML-ready compute. Next, please. And here you're talking about things like using a compute-aware platform like Azure Machine Learning, SageMaker, Kubeflow, Iguazio, things that understand ML, or you can bring your own infrastructure. Next slide. You'll add source control on top of that. Next. And then you'll use a CI/CD system that understands not just how to build and roll out, but thinking about things like ML-specific domain. Next slide, please. Today, we're going to be talking about 3 specific choices that we made here because these are the ones we're familiar with, but truly, you can use anything to achieve what you just saw. With compute, next slide, we're going to be starting with Azure Machine Learning. Next. Azure Machine Learning, you can see that here. It's a graphical and API-driven development. Next slide. And it really is open to any framework. You can use TensorFlow, PyTorch. It goes end-to-end across the skill levels. Next slide, please. For source control, obviously, we're going to be talking about GitHub. Next slide. GitHub is the location across the web for developing and collaborating with fellow folks. Gives you workflow, gives you automation, and security and compliance. Next slide, please. And for CI/CD, next slide, we're going to be talking about GitHub Actions. GitHub Actions is a new release, not incredibly new, but it is integrated into the GitHub platform, whether or not you're on the cloud or on premises. It gives you a rich CI/CD system that is right next to your code, and you can take actions immediately based on things that happen in your code. Next slide, please. Sorry, I talked about all this. Next slide, please. So with that, we are offering a complete solution to help you build MLOps using GitHub tools. It gives you all that versioning, knowledge sharing, and collaboration already present on GitHub, but then folds in the automated testing, model training, review, and deployment that you would expect from any ML-aware CI/CD system. Now, that's a lot of words. With that, I'd like to turn it over to Marvin Buss, who will be demonstrating some of this using some of our new templates.
Thanks, David. So now we have seen all those different tools which are available and which are kind of awesome, right? And which already simplify the MLOps process, kind of. But again, yeah, they kind of feel detached from each other and they are separate from each other, right? And that's why, as a first step, we have actually built Azure Machine Learning specific GitHub Actions. So we have built specific actions for those tools, and we have those. We have built those modular actions, which you can now use to really simply set up an MLOps process based on the tools that we have already discussed quickly. So those are used and built for Azure Machine Learning and can be used within GitHub. And what we came up with as a first step is 5 separate GitHub actions. First one, the workspace action, which you can use to create a new Azure Machine Learning workspace or connect to one. Then we have a compute action, which handles all compute target related actions or tasks. Then we have a one action, which you can use to submit just a training script or a complete pipeline of training scripts to Azure Machine Learning and execute it somewhere else. Then finally, we have also a register model action, which you can use to obviously register a model in Azure Machine Learning, which can be located already in Azure Machine Learning or in your repository. And then finally, we have a deploy action, which you can use to deploy an action to a Kubernetes cluster or to a container instance. And all those tools and those actions are already kind of nice because they tightly integrate into GitHub. So you can now use them in your workflow, but still there's more that we can do. And that's why, which you can see on the next slide, we have also come up and we have used another feature on GitHub, and that's GitHub templates. So we have created some template repositories, which you can now use to set up an MLOps process in no time. And that's something I want to show you in the next video. So this is the simple template. We also have an advanced template. The reason why we call it simple template, because it just includes a simple workflow that just runs from training to deployment all the way through and combines everything into one workflow. Please click on to show the video. So what I want to show you now is actually how the setup process is looking like and how simple it is.
Sorry, Marvin, we'll just take 1 second to answer a quick question, if that's okay, before we dive into the demos.
Sure.
So we have one here from Rajesh, who's asking, how do GitHub Actions relate to pipelines in Azure DevOps?
So the way to think about it is the two are complementary. Azure DevOps obviously has a deep lineage in enterprise-specific requirements, and GitHub Actions is focused on GitHub. I would expect the two to continue to merge and get closer over time. As you know, GitHub is a Microsoft company, and us having two enterprise-ready MLOps or DevOps platforms is probably not going to last forever. But for now, they are separate.
Thanks, David. That's great. And we'll just take one more question. This one is about whether GitHub Actions are compliant with the public cloud as well.
Absolutely. You're actually going to see here something where you are interacting and driving MLOps workloads on a public cloud. So you'll see us embedding, in this case, the Azure SDK, but it could be the Google Cloud SDK or the AWS SDK inside an action and then executing that action simultaneously. So rather than give it away, let me hand it off to Marvin to demonstrate how this is going to work.
Yeah.
Perfect.
So,
thank you. And we'll also start the poll now. So if you guys could please take part, that would be great. And I'll hand it over to Marvin for the first part of the demo.
yeah, so what we want to do now is actually show you how simple it is to set up such an MLOps process based on this repository. So you can just click on the green button to actually create a fork in your organization, and then create a repository from this template. So yeah, again, as mentioned, this essentially creates a fork under your organization. And now you actually only have to do one or two simple steps to get started with MLOps on GitHub and Azure Machine Learning. So I think the video stopped.
Yes, sorry about that. Just 1 second.
No worries. So yeah, there we go. So as you can see, I just use this template now. So this generates a new repository under my organization. And now all I have to do is actually create a service principal in Azure so that my repository is actually able to connect to Azure and interact with the workspace that I have in Azure and train some Python scripts remotely on Azure from a Git process. And what you should see in a second, and I think the video stopped again, sadly. Yep, so what you can see here in the README, there's also some instructions available, and there's also a CLI command available, which you can use to just create the service principal then on Azure. So let's switch to the Azure subscription that you have, and if you don't have a resource group set up yet, you can also create a new one, which I'm showing here as well, in which you then will create, or in which will then an Azure Machine Learning workspace will be created for you in this resource group later on as part of this template. So now we can actually go to this new resource group that I just created, and we can now use the CLI command that I've just copied from the repository. So I can just start the Cloud CLI. There's already the Azure CLI installed. I can also install it locally and then create the service principal from there. But essentially all I have to do is copy this command and then change a few placeholders in this command so that the right service principal is basically created and that the Git repository can actually, or the worker can actually interact with my Azure subscription. So here, I just have to select a new name for my service principal. That can be any name that is available and that I want to use. Then as the next step, I just have to look for my subscription ID that I want to use. And that's also available. And that's something you can see here in the resource group view. So you can just copy it from there. I just have masked that so that you can't see my subscription ID. And then you also have to provide the resource group because we are suggesting to scope the service principal to the resource group scope, basically. So then I just copy and paste the resource group name here and then I hit enter, and that's essentially creating a JSON output for me. So what I can see here, that's the JSON output. So I can just copy that. And now we can go back to the GitHub repository. So as a next step, we just have to provide that as a secret. So that basically the runner which executes our workflow can actually then interact with our Azure Machine Learning workspace and with our Azure subscription or Azure, the resources which are in our resource group, basically. Then I just paste the JSON output in here and save the secret, essentially. So then I can go back to the code section. And then there's one last thing that I have to do. I have to provide some parameters on my workspace that I actually want to use. And since I don't have a workspace set up yet, I can just pick any name and the workflow will actually create a new workspace for me automatically. So I don't really have to do anything besides that. And then I also have to provide the resource group because in some cases the service principal that I'm providing might have access to multiple. So I just have to provide this name here as well. So of the resource group that I've just created, paste that into the file itself again. I think the video stopped again. So yeah, there we go. So then I just paste the value in here and then I can start committing the changes. And what this does now, it triggers the workflow that we have already set up for you. And what you can see here now is the workflow that was prepared for you. So you don't have to go anywhere else and figure out how you can use those GitHub actions in combination and within a workflow. It's all set up for you and you can just use this template and get started easily. The first one, it's gonna take a little longer because it has to set up quite a few resources for you. It has to create a new workspace, which consists of a couple of sub-resources. Also, the first training one is going to take a little longer because in Azure Machine Learning, it's all Docker-based and conda-based. So it has to create some environments for you and Docker environments and Docker containers, actually, that will be executed. So that's why it's actually taking a little longer the first time. So all subsequent ones will probably take around 5 to 6 minutes but that's actually for training until deployment, right? So the whole process, if you want to go all the way through from training to deployment, it's going to take like 5 to 6 minutes, which is kind of cool. And you don't have any, so if you imagine you started from scratch with nothing, and now you have a fully MLOps process set up for you with just a few single clicks and generating one service principal to get started. It's all handled for you besides that, and you can basically automate your full MLOps process and your data science process from a Git-centric process. And in a few seconds, the deployment will happen and will finish here as well in the video. You can also look at the repository that we have shown here. Actually, the one which is the template repository, there we have also the video provided. And if you want to go through that again, you are happy to do so. So now the deployment actually finished. So now we can go back to our resource group and you can see it was all created for you. So here is your workspace that was created for you. And now you can actually also go to the Azure Machine Learning Workspace Studio, which is another front end for your workspace, and where you can now see what has been created for you automatically just by clicking on a few buttons. So there's a compute cluster created for you automatically on which all the training will be executed. Then there's an experiment and a run that appears, which actually is an execution of the training script with a certain set of settings. And here you can see also some results. And then when we go to models, you can also see that there's a new model registered in your workspace. And in artifacts, you can also see the model file that was registered here based on that. And if you go to endpoints, you can also see that there was a model actually deployed to an Azure container instance, which is healthy and which you can actually now use the scoring URI to send data to it and get prediction results, which is kind of awesome. And that with just a few clicks, you are ready to do all that from scratch. So you started from scratch, you had nothing, and now you have a fully set up MLOps process with Azure Machine Learning, with remote compute, and you can even deploy a model. And with that, I want to hand over to Xander, who's going to show you that all in a live demo on how you can use all of that now live with some nice additional GitHub features and how this looks in a real workflow.
Thank you so much, Marvin. Before we hand it over to Xander, we'll just start our second poll, and please do feel free to fill that one in as well. And like I said, we're going to be sharing the results at the end.
All right, thanks, Marvin, for getting that set up. So in this scenario, I'm working with Marvin, and we're working on the same repository. So you can see here, I'm working in this MLOps repository that was based off the template, ML template Azure in the machine learning apps organization. And so what I'm going to do here is I'm going to modify this template and show you how we can kick off an automated training and deployment process based on the change of code I want to do. So in this case, I'm going to change the model. There's a k-nearest neighbor deployment. I'm going to change it to a support vector classifier. And to do this, we're going to use a fancy new feature that was just announced at GitHub Satellite a few weeks ago called code spaces. And so when it's enabled on all of your accounts, you'll eventually be able to open new code spaces here. I have one already set up, so I'm just going to jump into that and we can get started. Okay, so I'm going to have to change the training script so that it works with the support vector classifier. So I'll update that here, and then I'll update the training here. Perfect. And there's one more thing I have to do, which is in the deployment phase, a scoring script is run. We enable to import my model. So you can see that as a data scientist here, I'm pretty much just, like, all I need to do is stay within the environment that I'm comfortable with, and that's Python. And so I haven't had to deal with, so far, anything. My environment was configured for me based on this repository. The repository was already configured, and I've done my exploratory data analysis, come up with some ideas, and now I just get to the meat of it here. All right, so now following the common Git workflow, I'm going to go and use, this is, for those who aren't familiar with code spaces, it's kind of an adapted VS Code Online. So it's connected to my Git repository. I have everything I need here, so I can stage my changes. It's similar. I mean, for those that use a command line, it's the same kind of thing. I'm basically adding, and then I'm going to git commit with a message, update to use SVC, and we will commit those changes. And so when I push to master, which is what's happening here, we're going to be able to see that the action has been kicked off. So back in our repository here, we have our workflows defined, our train and deploy workflow, where we're using the AML actions, Azure AML actions, and that's going to be triggered on my push to master. Now that can be modified, and Marvin's going to show you a little bit more about that later. So we can see that the action has been kicked off here, complete. But what's really awesome about this is, all the changes I've made are going to be visible in GitHub, and so I can tie back a deployment to the actual commit, and I can see the changes, and everyone can see the changes and kind of have that understanding. Jump into one that is already completed here, so we can see what ran through the steps that you saw in that workflow YAML. And here we are, we submit my training run. And so this is running that Python script that I was editing. That will complete, and then I have my metrics printout here. And this is also available in Azure ML, but I don't even have to go into another tab or into another environment. I can stay right within GitHub, and I've got my metrics here, and then I've got the registration of the model, which happens post training, and then finally it deploys. And so I've deployed to an Azure container instance in this, scenario, but that can also be to the AKS service that's provided by Azure. Perfect. So, I mean, this just goes to show how easy it is, and for me as a data scientist, to stay within my comfort zone and you know, abstract some of the stuff that I don't have trained, like, you know, Docker, Kubernetes, etc. And that's all I have now. I'm going to hand it back to Marvin, and Marvin's going to run through a bit more of a demonstration that expands on what we've seen here, and shows how we can customize it, or you can customize this to your data science team's workflow. So I'll stop sharing.
Thanks, Sander. So we should see the slides again in a second. There we go. So what we have seen now is a really simple workflow, right? And with just a few clicks, you were able to start with a simple MLOps process, and you didn't really have to do anything but just setting up a few secrets to get started with this. Can you please go to the next slide? Yeah, thank you so much. So what we have seen is that was just a simple workflow, right, which runs through and which combines everything into a single workflow. But then we have obviously many use cases, and many customers obviously want to have some manual processes in between, right? So you don't want to just, every change shouldn't just be pushed to the production deployment, obviously. So that's why we have this modular design of actions, and that's why we have 5 actions available, and you can use those and arrange them in a way that fits your workflow. And what is shown here, for example, and that's something I'm going to show you as well in a second, is just a different setup where we now split the training and deployment from each other. So, and in between, we are using some pull requests to actually handle the approval process, and to also get an overview of what has been happening on the Azure Machine Learning platform, how did the training perform, and how did everything run before we actually approve some deployment process. And that can be extended, and that's something actually we are working on. And that, please go to the next slide. And that's something we are actually still extending with additional features in the future. So there's more to come, but please go next. So what you can see here now is Sander also has been working on this, and he also now changed the training test size. And he wanted to look at those changes and created a pull request. And here you can actually see then and track basically what changes he has made. And opening with this PR actually triggered a workflow, actually the training workflow. And all this then has been executed on the Azure Machine Learning platform. So it has been training a model, and there was also a model registered. But what this workflow also does, it writes back information from the run, like the metrics that have been collected, but also the model name and the model version. So, and what we have also done is we have also enabled / commands to now trigger additional workflows from here. And I can now basically provide some details of what I want to do and kick off the next workflow, which in this case is the deployment workflow. And again, here in the command, we have specified that we don't want to run the test deployment, but only the dev and prod deployment, which has also completely run through. And this workflow actually also writes back information like the scoring endpoint and the Swagger URI. And now I'm ready to use this endpoint and send data to it to get a prediction from the model itself, which is super cool. And again, this is another template that we have made available, and all those actions are live. And this is just a different workflow of how, and shows how you can also arrange those actions so that it actually fits your needs. And there are different options available, and you will see more to come in the upcoming weeks and months. So with that, I want to hand back to David and with some closing words.
Thank you so
I
much.
guess now I'm going to present our demo. So Sarah, maybe you can go back to the slides for the 3 slides we have. So this is Yaron from Iguazio. This is really great, and we love the collaboration together with Microsoft and GitHub on this approach. And what we're going to show you is how to do the same thing using an open source framework that we developed. I actually did the work myself, so it shows it's not too complicated. So I'll show you in a minute how we've integrated it all. Essentially, one of the problems that we're trying to solve here in Iguazio is this automation of all this flow from development of code, models, data engineering code, etc., all the way to production. And we're using various automation tools. Most of them are open source. Many of them we've developed and contributed back into the community. And they deal with all those different steps. So Sarah, next. One of the things that we developed is a framework called MLRun. I'm going to demonstrate that, which is essentially sort of an end-to-end orchestration tool on top of things like Kubeflow and all the CRDs in Kubernetes, which are very DevOps oriented. We want to make everything accessible to the data scientists, as well as address it in a more holistic way, you know, add AutoML and hyperparameter tuning and tracking and automation of deployment through serverless technologies, etc. So there are 2 different ways of working in this framework or using this concept. The first one is using an interactive way. And the interactive way is I'm taking my Jupyter or my PyCharm or GitHub code soon, assuming they'll give me a license very soon for that, and it will go out of beta. So I'm writing some code, and then when I want to productize it, I may need some manifest. My manifest may define, you know what, I'm using this base image. I may need some GPU resources. I want to distribute my workload across 5 containers, not necessarily 1. I need some data, volume mounts, etc. So I can express those in an abstract language. And then I combine those 2. Sometimes I need to build an image because I have a bunch of dependencies. You know, I need TensorFlow package, this and that, conda environments, all that stuff. Sometimes I already have the image, so I can just go and deploy my work on top of a Kubernetes cluster, preferably using some serverless technology, so I don't need to deal with, you know, Docker build and logging, monitoring, all this sort of nightmare. So now once I've run a single step, at a certain point comes a stage where I want to run a pipeline comprised of taking some data, running analytics on that, running training, validation, everything is good. I want to move into production and form a pipeline. When my function is okay, I may also commit that into a code repository like GitHub, and maybe add some documentation so it's well understood. And if it's already committed into a good Git, I may pull it into a workflow. And I'm going to show you how it's done. So I can essentially form different steps, one for training, one for validation, test each one individually, and then just collapse everything to a single pipeline. So that is more the interactive way. Next. But there is a different way, which is more automated, and it's not one or the other. Sometimes you need the interactive way, especially when you start, you write some code, you want to test it in a standalone, but at a certain point, you want to form a CI pipeline, pretty much like we do with code, with Jenkins and other tools. So then I may provide my code and manifest, you know, which could be provided as a code or a YAML file, and push it into a repo. Once I push this code and manifest into a repo, that may trigger some tool that will go and build everything for me. If it needs, it will build images. If not, it will just run a pipeline. And once the pipeline completed, it is going to feed back the response of the pipeline, essentially all the results back into the commit PR. And while doing so, it can track everything, experiments, runs, data, lineage, all those things are done fully automated. This demo is actually, you see the Git URL, and you can just open it and clone it and work with that. So I'll share my screen now. 1 second. The repo that I just mentioned, everyone can go and clone that and use that. Essentially, what it's using is 3 tools. The first one is GitHub Actions for actually triggering the workflow. It's using Kubeflow pipelines, which again is open source project, very dear to David's heart. And then we have ML run, which is sort of an end-to-end orchestration on top of all of those things and make it simpler. And how does it work? Just as I outlined before, essentially I'm going to push code or artifacts and everything else is going to happen automatically. Once this is going to run, then essentially as I create a PR, and I'll show that in a minute, I can just say /run and I could give it other hooks. Once I'm trying to run this pull request, it's going to shoot a message telling me it's starting the pipeline. If I want to have you know, a URL for seeing the progress, and once this pipeline finishes, I'm going to have a dump of all the results of my pipeline of each one of the steps of the pipeline independently. And if I want to go into Kubeflow, this is a Kubeflow planted into the Iguazu platform as a sort of a managed service, but you can use the open source one just as well. You can actually see the progress of the pipeline, or you could use the ML run utilities for tracking and seeing the progress. Okay, how it works? You just need to clone this repo using this button and fill up some secrets, assuming you have a cluster set up and there are instructions how to set up Kubernetes and all of those tools that we use, and ML run and Nucleo and other things underneath. So, and if you just want to play without installing anything, just click try Iguazu and you'll get cluster ready to go. So the general idea around ML run is that I can have a notebook. I have here a project.yaml, which is in the root of the repo. This is defining all the manifest of everything I'm doing. And I have a notebook, which is actually generating this project and this workflow. My notebook is relatively simple. It may have a code, in this case, like a data ingestion code. It's a function that generates an iris data set, you know, well-known data set. I can take this and I may annotate within my notebooks all sorts of things like image requirements, etc., which will then translate into the manifest, which I mentioned. I could form a project because we want everything to sit under a certain project, artifacts, data, you know, executions, etc. And I could just go and execute my code locally with a wrapper that does recording of all the experiment tracking, lineage, all that is done automatically. At a certain point, I want to build a full-blown pipeline so I can go into, as I mentioned, library functions that were published previously for classification, validation, building model serving functions, validating the model serving function using a live action. And there's this nice function we added for the GitHub Actions integration. And once I pulled all those functions together, I need to build a graph that tells me what is the execution story of all of this thing. It's using Kubeflow pipeline DSL language, sort of a graph description language, where I take each one of those functions and I daisy chain them. I say this step fits that step. You know, the output of the training is moving into the validation. The output of the training then goes into a deployment function, which generates a serverless function that actually serves the model. Once I have a serverless function running my model, I can actually run another testing utility which bombards my serving function and validates that it actually has a decent performance and it works in production and all of that. So I can form a very complex pipeline using this DSL language, and then the only thing I need to do is run the pipeline. But in this case, I don't necessarily want to run the pipeline interactively. I just want to save my entire project with my workflows. Once I'm doing this save, it's essentially just going to generate this project YAML manifest and the workflow file, Python file. You see this manifest tells me that I need to pull some functions from remote, which are also, by the way, in GitHub, in the function repo. And there is also some function which I embedded into my manifest. So I have a manifest that describes my functions and the relations of my functions. And then when I open a PR, let's assume I wanted to change something in my workflow and change the test set. Instead of having 10%, change the test size to 20% of the data. By the way, this is an auto ML function, which can essentially run multiple algorithms in parallel. You can see here 3 different algorithms. And when I open the PR, I can essentially, I create a pull request, and at a certain point, I want to run a testing against my my new changes So the only thing I need to do is essentially /run in my pull request. Once I'm doing /run, the bot will automatically respond with, this is the commit ID, which is important. We'll see that later. This is the pipeline ID for Kubeflow. If I right click, it opens MLrun UI to track the progress. And after a while, I get essentially the results of the pipeline. So we have several steps in the pipeline, as we mentioned. We have the training step, and I could see the different artifacts that were generated with the URLs. I can see the different accuracies that were generated. I have the test validation on a bigger data set. Again, what were the results? I have the model testing function that actually used the real live serving function and tested things like average latencies of my model behavior. So I can see all of those results. And then I could just go in and do /deploy or something like that, which will migrate those functions into production. Now, let's go, for example, to the training function and right click and open that in the MLrun UI. Again, we have single sign-on mechanism here, so it's not that every one of you can just open this URL. And then I'm essentially going into the training step, and I could see that the training step ran those 3 different algorithms. Each one has its own results. I can go into the artifacts, look at the ROC curves, the confusion matrix, all those things that were generated from my training. And this is linked directly into the Git repo. So this way I can just go and play around. By the way, we can also generate a hook that generates a Slack message. So in parallel of getting this PR comment, you can also get a Slack message for that. Now, once we've deployed the model, essentially what it did on the Guasio platform, it formed a new serverless function for model serving. And you could see that the final 6 digits are the commit result, the commit ID results. So essentially for every commit, I'm generating a new function. Now it's not really wasteful because you can see those functions are scaling to 0. So I can have as many functions as I want, 1 for every commit. What really matters is the API gateway that's going to serve. And right now I see that this one is connected to the API called demo development. And I could just go to a different API, and let's go and edit my API and do a canary deployment. Let's add another thing and just give it like some percentage and save. And now I have a A/B testing essentially, or a canary deployment that serves both versions of the model. By the way, everything I did right now in the UI could be done through APIs. Just as well, everything is APIs. And by the way, Nucleo is another open source project, which is a very high performance serving, serverless processing engine. So that's on that front. As I mentioned, everything also is shown on Kubeflow. So you could see all those steps and all the data and metadata, the ROC curves, the confusion matrix. When I'm running, for example, the deployment, I can actually see the progress of, logs are evicted already, but I can see the progress of the deployment and what was the IP addresses that were generated. When I'm testing the model, I can actually see like a chart of the latencies and variances, etc. So with that, you can see that we can automate the entire workflow and make it very simple. The only thing you need to do is just edit a simple notebook and type your code. You could actually take this notebook, instead of changing this iris generator to something that does some other interesting analysis on your data, which you pull from S3 or whatever, and run the same pipeline against your data, and you have a full-blown machine learning pipeline that drives everything to production. Okay. Okay, so you want, let's go one by one. I don't know whether we've answered all the questions. You want me to read them out? So the first thing, the demos, the videos and recordings are all going to be online afterwards. You're going to get an email notification on that. How does the Docker Kubernetes configuration completed automatically. It depends on the solution. On my solution, part of what MLrun does is essentially programs Kubeflow and generates the Docker for you from the code. So essentially, you don't need to do much beyond giving it, setting up the system. Once you write some code in a notebook and you do this, what we call code to function, then it automatically generates the containers and everything for you and wraps up the pipeline from your DSL. Maybe David, you want to answer some of those questions?
I'm not seeing the list. I have everything answered in the 30 questions. There are a few remaining.
Yeah, there's one new one that we can answer that just came in. Can the same GitHub actions be executed as part of an Azure DevOps pipeline?
Yeah, so think of them as complementary to each other. You could have GitHub Actions call Azure DevOps. You could have Azure DevOps call GitHub Actions. Everything is SDK based, so you can easily go back and forth between them. As far as reaching out on GitHub Actions and MLOps, we are going to have a Slack channel where you can do this, or you can always email me. I pasted my thing into one of the questions, but I'll paste it in the chat right now. Feel free to email me at any time. That's daron@microsoft.com, and I'm happy to help you route your questions to the right people.
Thanks, David. And we'll take one last one. This one's for Yaron. Does Iguazio have a native IDE environment?
Yes, of course we have. You mean IDE in terms of coding? So one of the things that we have part of the platform is managed Jupyter. What's pretty awesome about it, it's a scale out Jupyter. You can actually run something within your Jupyter that will scale across multiple containers and dynamically assign things like GPU and data resources. So you can build a pretty large job. We also have customers that use other tools like PyCharm, VS Code, etc. Another interesting thing in PyCharm, you can actually split the front end from the back end. So we've been running essentially the back end on the Kubernetes cluster directly attached to the data, where the PyCharm front end is sitting on the customer's laptop. And all the things, by the way, that I've shown here is remotely accessible. You can actually have your own PyCharm or Jupyter or any other IDE access the system through remote by only setting 3 environment variables with some secrets and API endpoints.
Excellent. Thanks, Yaron. So we're going to share the results of the poll with you now. And we also want to show you we're at the end of the webinar right now, and we have a couple more resources that we invite you to take a look at. This is our MLOps resource page, and there are links here to our previous webinars, a few of you were asking about that, for viewing on demand. Lots of great blogs on MLOps, videos of industry experts from Netflix, the New York Times, Uber, and many others presenting their insights and best practices on MLOps. And we're also starting a new community called MLOps Live that David touched upon a few seconds ago. And this is a place where you can learn about this topic, share resources, ask questions. There were some really fantastic questions here at this webinar today. And you can all be the very first ones to join our community on Slack. We'll send the link in the comments just in a minute. And if you'd like to get in touch with any of our speakers, you can find their details here. And do let us know if you have any comments or feedback about today's presentation and what you would like to hear about in our upcoming episodes. So with that, I'd like to...
And maybe just adding to Sarah's point on the community, the reason that we've sort of opened it is because we're keep getting questions over and over after the webinars about technical things that came from the webinar itself. The last webinar was about auto drift detection, where Or showed a brilliant demo. And so we are getting so what we decided is having a community where we will put our data scientists and our, also some of the consultants that we work with us and partners that we work with, et cetera. And over time it will grow, and it will allow, this is really the place for you guys to just shoot a question. I'm trying to do this, I'm struggling. We're going to share, like, people can have reviews of products that have tested in this and share comments, interesting blogs that someone have read and he wants to share. So we're going to have a few channels on those, and also share all the videos and presentations that were made in this webinar series.
Yes, absolutely. And David, did you want to say any parting words before we end today's webinar?
No, the big thing for us is that this is very much an open platform. We'd love your feedback. Please come and join us. But this really is our core philosophy. Like, the more that we can help the folks on the front lines, and not just data scientists, but real, end users get access to these models and move into production, the better off we all are. And that's very much our hope here behind open source projects like this, is to abstract away a bunch of the stuff under the hood into very clean interfaces, and then let the people who are doing the hard work of building these great solutions step forward.
That's so true.
And part of what we have also, I didn't show that, but in the MLRun/demos, we created, I think there's like 5 or 6 different use cases end to end that demonstrate also how you build, for example, churn prediction, how you build predictive monitoring for manufacturing facilities, etc. So, and showing the aspects of sort of the MLOps practice, because there are many Kaggle notebooks that will show you how to build something, but it's not necessarily going to drive you to production. So what we've built is use cases anywhere from data collection with streaming and things like that, all the way to model serving and the APIs and real-time feature stores on how you build those in a more production-oriented fashion.
That's great. Thank you so much, David, Marvin, Xander, and Yaron, for the great session today. And thanks everyone for joining us. We hope to see you on our Slack channel, and we hope you keep asking us really great questions and keep the discussion going. Thanks, everyone.
Thank you for the opportunity.